Okay, we're in section 4.8, which we're going to do in two parts. The first part we'll do examples 1 and 2, and the second part we'll do the rest of the section. So first of all, theorem 4.7, the base angles theorem. If two sides of a triangle are congruent, then the angles opposite them are congruent. Now let's review. If two sides of a triangle are congruent, what kind of triangle is that? It's isosceles. So we now know that if we have two sides, if we have an isosceles triangle, which means these two sides are congruent, if we have an isosceles triangle, then we know that the base angles are congruent. And we can also flip that around. Theorem 4.8, the converse of the base angles theorem. If two angles of a triangle are congruent, then the sides opposite them are congruent. So you can also define an isosceles triangle by the base angles being congruent. So I have an isosceles triangle because I know the base angles are congruent. If these are congruent, then those are congruent. If these are congruent, then those are congruent. Example 1. In triangle DEF, segment DE is congruent to segment DF. Name two congruent angles. Okay, using the base angles theorem, we can say that angle E is congruent to angle F. Wow, that's deep. All right, you try. Copy and complete the statement. I'm going to go ahead and push pause, and you guys are going to finish it. Okay, push pause. Okay, that's number 1. If HG is congruent to HK, which I marked in the diagram, then angle G is congruent to angle HKG. Notice you need 3 letters to name this angle because angle K could be that angle or that angle. Okay, push pause and do number 2. Okay, if angle KHJ is congruent to angle KJH, then side HK is congruent to side KJ. Okay, there is a corollary to the base angles theorem. If a triangle is equilateral, then it is equiangular. Corollary to the converse of the base angles theorem. If a triangle is equiangular, then it is equilateral. Basically, if all the sides are congruent, then all the angles are congruent. If all the angles are congruent, then all the sides are congruent. Again, very deep. Okay, find the measures of angles P, Q, and R. If you know all of the sides are congruent, then you know all of the angles are congruent. I'm going to name one of these X. And since we know they're all the same, we can say 3 times X equals 180. And we know it's 180 because of the triangle sum theorem. So we can divide both sides by 3 and say X equals 60 degrees. So all angles are 60 degrees. Okay, you try. Find ST in the triangle at the right. Push pause. If one side of this triangle is 5, then all the sides are 5 because an equiangular triangle is also equilateral. Pretty simple. Let's try another one. Is it possible for an equilateral triangle to have an angle measure other than 60 degrees? No. Okay, the triangle sum theorem and the fact that the triangle is equilateral guarantees the angle measure of 60 degrees because all the pairs of the angles could be considered base angles in that isosceles triangle. Okay, if you have an equilateral triangle, then the angles must be 60 degrees. Okay, we're going to save example 3 for part 2. Good job today.